Okay, in the last lecture, we discussed about any body which is under 3 force and is in equilibrium. Now we will do a single question for that. Let's suppose if there is any body, let's suppose this is a question related to the body which is under the action of 3 forces. Let's suppose there are let's suppose there is any body. Let's suppose there is any body, okay, and in this body 3 forces are acting, right? And in this 3 forces are acting, okay, and they have given and they has provided us that F1 and F2 are parallel to each other, they are what? They are parallel to each other. Then the third force F3 should be parallel or should be parallel or not. This is they have asked, okay. So let's suppose this is the first force which is acting on the body and is in this direction. Any doubt? I think that we should not have any doubt, right? Okay, then no doubt the second force F2 has to be parallel, but it has to be in the opposite direction. Right? Okay, then this F2 will be in this direction. Okay, this F2 has to be in this direction. Okay, no doubt. Now see, these two forces are parallel to each other. Let's suppose this is the axis of the body. Now these two forces are parallel to each other, and we know that the parallel forces or the parallel lines meets at infinity. So somewhere they will meet at infinity. Okay, now we have to remind the condition which we learned, that any body which is under equilibrium under the action of 3 forces, then what was the condition? That the 3 forces which are acting, they should meet at a single point. Right? Then just think over it that what could be that point where all the 3 forces here they are meeting. So what could be the point? That point is no doubt is at infinity. Why? Because these 2 forces are never intersecting each other, because they are at infinity. Therefore the third force F3 has to meet at what? Infinity point. And therefore the third force also has to be parallel. The necessary condition which we got, that this F3 force has also to be parallel. It should also be parallel to F1 and F2, no doubt, and should meet at infinity. And we know that when 3 forces meet at infinity, the closed loop formed by those 3 forces are 0. Getting it? Okay, chaliye. Okay, then this is the simple example for this. Okay, now next topic is equilibrium of a body under two forces and a torque. Equilibrium of a body under the action of 2 forces and a torque. Okay, no doubt, no issues. Let's read it. Okay, for example, I have any 2 links. Okay, now I am taking the name of the links, so no issues. We will discuss it later what are the links, but for simplicity, for now we know that links are something which transmit motion from a body to another body, getting it without undergoing any deformation. Okay, for example, I have any revolute pair. Which is fixed at this point. This is my revolute pair which is fixed at this point. Okay, let's suppose, okay, this is revolute pair. No, you know what the revolute pair are the pair something which revolves with respect to which revolves with respect to each other. ठीक है, something like this. If I put a point here, ठीक है, if I put a pin here, so these two fingers will try to rotate with respect to each other. So this is a kind of a turning pair or a revolute pair, right? Okay, we will learn in detail about these things. For now, just listen and just understand this much. Okay, let's suppose there is a force acting on this direction, F1. Okay, let's suppose there is a force which is acting on this direction. Any doubt? No, right? And there is a torque, T, which is acting in this direction, and let's suppose this perpendicular distance, is h for now, and let's suppose this perpendicular distance for this is now. Okay, any doubt? No. Now see what I will think. Now I am reading the equilibrium of a body, and now this body to be under equilibrium, what I need, either the body should be at rest, or the body should move with a constant velocity. So here the body should be at rest. Okay, now if I draw the free body diagram of this body, if I try to draw the free body diagram of this body, okay, so at this joint, what I will get, see, this force is trying to move this body in this direction, so the reaction, so this body is just opposing it, isn't it? So this joint is just opposing it. Okay, so the force which will generate here, or the constraint which will generate here, will be in this direction. F2 will be in this direction, isn't it? Say yes or no. Exactly this direction, right? Then no doubt, now it is very clear that F1 magnitude has to be equals to F2 magnitude, isn't it? Otherwise, if this force is greater than this one, so this body will move and if this two forces will be greater, if any force will be greater, then this body will try to move, try to do rotational motion plus translational motion. It will go like this and it will move like this, isn't it? Okay, so but we know that the body is in equilibrium, and in equilibrium there is either no velocity or is no acceleration. Basically there is no net force, right? Okay, so F1 has to be equals to F2. Secondly, F1 and F2 should be opposite, isn't it? F1 and F2 should be opposite, right? And the third, F1 and F2 should be parallel to each other, right? And the fourth important condition, applied torque should get nullified, and the applied torque should get nullified by the external applied force, isn't it? That is F1 and F2. See, what I'm trying to say is, F1 should be equals to F2, F1 and F2 should be opposite, F1 and F2 should be parallel, applied torque should get nullified by the externally applied force. What this point is trying to say is, see, this applied torque will try to rotate the body in this direction, that is in clockwise direction. So what we need, we want the body into an equilibrium, then this torque has to get nullified by some means. And what is this mean available here? This is the mean available. These two forces will try to nullify the effect of this applied torque, isn't it? So what is this saying? Applied torque should get nullified by the externally applied force. That is torque should be equals to F1 into H or F2 into H. ठीक है, and we know that torque is equals to force into perpendicular distance. So this is the direction, this is the force, isn't it? So this is the force and this is the perpendicular direction. This is the force, say yes or no. This is the force and this is the perpendicular distance. There. So, and what is the fifth necessary condition? Sense of couple formed by F1 and F2. F1 and F2 should be opposite to the applied torque. Getting it? And if these all conditions will be fulfilled, then this body will be under equilibrium. Okay,